All right, guys, here's our first example of a confidence interval for the slope of a regression line. This example comes from chapter 3. Perhaps you remember it. We're talking about non-exercise activity as it may explain fat gain. The data is listed here. These are my x and y. It's in two rows, but x and y there. And the computer output is here. And in the last video, we went over what these values were, at least the ones that are applicable for this problem here. So we want to construct and interpret a 90% confidence interval for the slope of the population regression line. That's our goal. So estimate the true slope, beta, of the population regression line relating NEA change, just go with it on my handwriting, to fat gain at 90% confidence. All right, step one. Step two is the plan. And in the first video I said, this is where most of the work is going to go, a CI for beta, which is what we're trying to do, has 5 conditions that need to be checked. And the acronym LINER may help: linear, independent, normal, equal variance, and random. For linear, looking at the scatter plot, we're reasonably comfortable that this is a linear pattern. So linear according to the scatter plot. Now you'd want ideally to take a look at the residual plot, because you're going to need it anyway for the other checks. And when I make my third video showing you the calculator keystrokes, I'll show you that. Ultimately, remember that the residual plot is the residuals, which are these vertical distances against the x values. That's what we'll be creating on the calculator. And as long as they tend to bounce around the line, kind of reframe it, it's going to end up looking something like that. And if I look at these points about that line, which would be the residual equals 0 line, I don't really see a dramatic pattern there, so I'm feeling pretty good about it. But you'd want to make that graph. So we'll say check resid plot on our calc. And I'll show you that in the next video. Independence statement is some comment about individual fat gain should be unique from person to person, should be independent. That's enough to say there. If it's truly a randomized experiment, and if we were told that this was a sample, yes we were, a sample of 16 healthy young adults, then we want to say that there's at least 160 similar healthy young adults in the population. So that addresses the independence within the group, and then the independence between individuals there. Normal. Our normal check is the residuals need to be distributed approximately normally. So we're going to either look back at our chapter 3 notes, or we'll show that on the calculator in the next video. But we'll say histogram of residuals is roughly symmetric, single peak, approximately normal, or very clearly not non-normal. Our equal variance check is something that we're going to also want to check on the residual plot. So we'll say resid plot and look for no heteroskedasticity. And again, that's just style points if you want to write that down. But we're looking for a constant spread across x, a constant spread of the y values from the line across x. But we'll show that on the calculator in the residual plot. And then lastly, they were randomly selected participants. And we'll move forward with all those conditions being met. So we're going to fit the equation b plus or minus t, and again, it's not the t from the table. We have to go look this up, times the standard error, which in this problem, my estimate for b, the slope estimate, is negative 0.0034415 plus or minus, I'll look up t in just a second, and then times the standard error, which is going to be that guy, 0.0007414. Now the t, again, not this one, the t for 90% confidence, and we had, let's see, 16 observations, so degrees of freedom. We'll sneak that in here. Degrees of freedom equals 14. N minus 2 for the regression procedure is 1.761 from our table or your calculator. When we work this out, we end up with negative 0.004747 to negative 0.002136. And our conclusion, we are 90% confident that this interval, negative 0.004747 to negative 0.002136, captures the true slope of the population regression line, relating NEA change to fat gain. All right, so the important pieces here are going to be getting this into your calculator, which I'll show you in the next video, how that then helps you check the conditions here, understanding what the values are in the table, and our procedures are always about the slope. We're not doing procedures about the y-intercept. So while if I ask you for the equation of the regression line, you would maybe want that number, we're ultimately not really interested in those. We want the standard error of b. We will use this number eventually, but it is not for the confidence interval procedure. That's going to be for the test statistic. And then these, again, go back to our regression fundamentals and otherwise aren't used in the procedure. So take a look at the next video, which has calculator keystrokes to get you the scatter plot, residual plot, and normal histogram, of the residuals, all those things.